The inscribed angle theorem can be used to prove a series of theorems relating some angles and circle on the Euclidean plane. And let's work on one of those theorems. The following theorem is called the two chords angle theorem. It says that if two chords intersect in the interior of a circle to determine an angle, the measure of the angle is the average of the measures of the arcs intercepted by the angle and its vertical angle. So let's look at the following figure to see what this theorem is talking about. For instance, the chord AC and the chord BD is intersecting at the point E, which is a point in on the circle in the circle. And on the other hand, we observe that uh, the angle AEB is intercepting the arc APB, while the angle DEC is intercepting the arc DQC. And the two chords angle theorem actually says that um, the measure of the angle AEB, which is the same as the measure of the angle DEC because they are just a pair of vertical angle. Well, but both of them is going to be equals to 1/2 of the sum of those two arcs on the circle, the arc DQC and the arc APB. And and this expression here is precisely the average of the measures of the arcs intercepted by the angle and its vertical angle. So, um, so it turns out this theorem is a relatively simple consequence of the inscribed angle theorem. So now let's try to look at the proof. Specifically, what we're going to do is going to observe that if we join point A and point D, for instance, then we will end up with uh, a couple of inscribed angle, namely the angle DAE and the angle ADE. So for the sake of convenience, we're going to denote those two angles as angle 1 and angle 2. So by the inscribed angle theorem, by the inscribed angle theorem, we have the following observation. First, the measure of angle 1 is in fact 1/2 of the measure of the arc DQC, right? The angle 1 is intercepting the arc DQC. And similarly, the measure of angle 2 is just 1/2 of the measure of the arc APB, right? Now, what we observe is that the angle, so now let's look at the figure. The angle AEB is in fact an exterior angle of the triangle AED, with the angle 1 and angle 2 as the non-adjacent angle to this exterior angle AEB. So if we put this observation together, we note that the angle AEB is an exterior angle to the triangle ADE. Hence, the measure of AEB. It's in fact the sum of the measure of angle 1 and the measure of angle 2, which is precisely the sum of the measure of those two arcs. And this completes the proof of this theorem.